Now we're going to talk a little bit more about different types of polygons. And some of these words you have already seen. Equilateral, for example. Equilateral means that all sides are congruent. So if we look at our example here to the right, all sides are congruent. You see the congruent marks. We have 1, 2, 3, 4, 5, 6, 7 sides. That means we have an equilateral heptagon. Or we have equiangular polygons. Equiangular polygons are polygons where all angles are congruent. Remember that from our triangles. And the example here to the right has how many angles? 1, 2, 3, 4, 5, 6, 7, 8. So we have an equiangular octagon. And then something that's a new concept for us at this point, regular. When do we call a polygon a regular polygon? A regular polygon is both equilateral and equiangular. And that's not always the case. But a regular polygon is both equilateral and equiangular. And let's look to the right here. We have 6 angles, 6 sides. So we have a regular hexagon. Okay, in the next example, find the measure of an interior angle of the indicated regular polygon. And when it says an interior angle, we're really talking about one only. Right? We have our formula, and the formula gives us the sum of all interior angles. Now we're supposed to find an interior angle. But what helps us here is that we're talking about a regular polygon where all angles have the same measurement. And in our example 5, we're talking about a regular heptagon. So n, the number of sides, is 7. And that's what we're going to use to find our interior angle. But first we need to find our sum. The sum is n minus 2 times 180. And if n is 7, we got 7 minus 2 times 180, 5 times 180, which is 900. So the sum of the interior angles, 900, has to be divided by 7. And what we get then needs to be rounded. So it's approximately 128.6 degrees for each of the interior angles. One interior angle has a measurement of approximately 128.6 degrees. So in our last part of today's tutorial, which was a little longer than usual, we are going to talk about exterior angles. And we're going to, in our exploration here, identify each exterior angle and calculate the sum of the exterior angles for each of the polygons. Now remember, an exterior angle is an angle that, together with our interior angle, forms a linear pair. That means together they measure 180 degrees. And if the linear pair is 180, then in this example where the inner angle is 50, the exterior angle has to be 130 degrees. And then we have, of course, 2 more linear pairs up here. The interior angle forms a linear pair with an exterior angle that the exterior angle has to be 120 degrees. And a third interior angle of 70 degrees will form a linear pair with an exterior angle of 110 degrees. Okay, then let's take our exterior angles, 130 degrees, 120 degrees, and 110 degrees, Add them all up, and what we get is 360 degrees, and that is the sum of all our exterior angles. Very good. Let's move on to our quadrilateral here on the right. We have 4 angles. First, we have a right angle down here at the bottom right, and then the exterior angle needs to be 90 degrees as well to add up to 180. Going counterclockwise, I have an exterior angle here of 89 degrees, an exterior angle of 88 degrees, and an exterior angle of 93 degrees here. So let's add them all up. 90 plus 89 plus 88 plus 93 will add up to 360 degrees, the sum of the exterior angles. And this is not a coincidence. The sum in both cases is 360 degrees, and that will lead us to our polygon exterior angle theorem. And that says that the sum of the measures of the exterior angles of any convex polygon is always 360 degrees. It's always 360 degrees. There's no formula, but it's always 360 degrees. But equally, you need to know this and you need to remember that. So mark it, circle it, highlight it, whatever suits you best. And by the way, also note the link that I put down here at the bottom. That is a link that goes to our favorite internet site, mathopenref.com, and you can play around there and try to understand how does it work with the exterior angle theorem. Why is the sum of the exterior angles always 360 degrees? But let's look at this next page together, and we have 2 polygons here with their exterior angles. If I take those exterior angles and put them all together at the same point, see what happens. We get to make an entire circle here. This is a circle, and as you know, a circle measures 360 degrees. And it doesn't matter what type of regular polygon it is. Let's look at our hexagon here on the right. We can do the same thing with that one. And as we piece together our external angles, we will see that yet again, will they form a circle, and that is 360 degrees. And essentially, another way to think about it is, even though we have more angles now, each angle is smaller, each exterior angle is smaller, because the interior angles got larger. We can use this exterior angle theorem, of course, to find things like solving for x. We have all our exterior angles here given as expressions with x, and you know this from when we worked with triangles. So let's just do the same thing that we always have. We add all these exterior angles together, add the expressions together, combining like terms only. We got 3x plus 2, 3x minus 5, 2x plus 3, 4x plus 10, x minus 10, and we got 2x plus 60. Now let's add these all together. All our x's add up to 15, and our constants add up to 60. And we know that this sum has to be equal to 360 degrees. So now let's go ahead and solve this, subtracting 60 from both sides. We get 15x is equal to 300. Dividing by 15, and x is equal to 20. And in our last example for today, let's find the measure of an interior angle and an exterior angle of the indicated regular polygon. So in the interior angle we find using the formula for the sum of the interior angles, which is n minus 2 times 180. And the exterior angles we find using the knowledge that the sum of all exterior angles is always 360 degrees. And we are talking about a regular polygon again. So all angles are going to be the same. We're supposed to find the angles for a regular hexagon. And hexagon means that we have 6 sides. Now we can do it using either of these two approaches, finding the interior angle first with a formula, or finding the exterior angle first, whichever way you prefer. But I'm going to go ahead and use the easier way. We have 360 degrees, which is the sum of the exterior angles, and we have to divide that by 6, and that'll give us 60 degrees. So we know that one exterior angle measures 60 degrees. Now, if one exterior angle measures 60 degrees, and let's draw a little diagram here, that always helps, right? We got a hexagon here, and we just found out that our exterior angle has to be 60 degrees. Now, if the exterior angle is 60 degrees, and together they form a straight angle, they are a linear pair, they form a 180 degree angle, well then the interior angle has to be 180 minus 60, which is 120. So that was the fastest way to figure out that one interior angle measures 120 degrees. Alright, that's it for today, and I will see you in class.